Now looking into the visualization of our material, we'd like to go ahead and look at the serpentine wall and how we can get an accurate visualization and also prepare us for later the fabrication elements. One thing to correct is obviously the offset of the slat needs to be internal, and we're going to look at how to make a more accurate rail and a piece that's a basic cut rather than this angled cut, which we can correct easily, as you'll see. Alright, so the first thing we're going to do is turn off the solver, as we're going to edit some values. Right now it's this offset is going into the rail. We want it to go the opposite direction, so we're going to change the expression in both the top and the bottom. We'll go ahead and enable the solver, and now you see it's on the right side. Okay, and this next code is a little more complex, but we're gonna go step by step. Pretty much, we created a line, and I'll turn these lines on so we can see them, for the internal part of this outer slat, both sides of the width. And since it's not 90 degrees, we have a little bit of a visualization issue. And what I want to do is actually go to the middle of this line to develop where we're going to make it so it's going to have a consistent detail on the inside and outside. So one of the first things we're going to do is we're going to go ahead and create a new line. And that line is going to be from the bottom, because we're going to now, obviously the top can change a little bit, but we want to have a consistent bottom. We're going to go ahead and connect the bottom points. And we're going to use this line to get a center point. And from there, we're going to choose a consistent detail that we can put on both on the inside slats and the outside slats. We can hide this. I'm not going to use that. All right. From that, we are going to take both the geometries of the two higher lines, and we're going to push down a little bit our other sets of code for right now. And we're going to use that soon, but one of the first things we're going to do is actually we're going to scale both of our lines for that outer slat. We're going to do it times 2. We're just going to put a number in there for 2. And this is only for getting a good intersection. And we're going to put that in both of these. We're going to scale these, and we're going to scale them according to their individual center points. So center points you'll find are very valuable. They help us organize lots of information. So now getting the center point of each of the curves, we get a chance to scale from the center. And I'll put them a little bit closer. And so we have now an opportunity to get a more accurate position for each curve for where we start a slat and end the class. So now let's look for the closest point to the curve. And now it's going to be based off this center point right here, hitting to the width of the slat on both sides. So that's going to be consistent on both sides, and you'll see shortly what I'm talking about. This is our point. We're going to get two of these, one for the top curve and one for the bottom curve. And you see that new line is going to be how we connect with the rail. The rail is going to extrude up at the bottom and down at the top, and in the middle it's going to be balanced. But now we have that much more accurate point for us. And so what we're going to do is, as we've taken care of this, there's one last piece of information, and that's going to be the distance. And what we're going to take the distance from is the distance of that inner curve, and I believe it's this one. It's going to be this line. This is our inner curve. You see there from the screen. And so that distance, we'll just go ahead and get it from the original points, and we'll make some of the geometry redundant. We're going to take it out later, or some of the codes. Okay, so now we have a distance, and that's all we need, pretty much a vector. We have this point and this point, and we're just going to pretty much copy our line from that information we have there. And everything we are doing, we can, of course, just simply copy over as we're refining both sides of the wall. Okay, so we're going to clean up a little bit of the points made and everything. Our division of curve is not as necessary right now to see. I'm going to hide those. And so now we have these two points. Those are all we need to go ahead. And this actually is going to be used later, but we're actually going to copy the geometry from this line to both of those points. What we can do with that is essentially just keep that inner height. We don't need to use two curves, because before the inner and outer slat were a little bit different. Now we actually have a proper piece of geometry. And what we're going to do is we're going to create a vector. And this is the basic vector is 0, 0, 0, 0. If we're going to subtract, and of course we'll test it just quickly, but we're going to subtract the location of our line from 0, 0, because that's going to be our move vector. So now we're going to move it, and what we're going to do is actually, we're going to actually be moving it from its current location to our new location, and we're going to have two of those. We'll put this out here, that to be clear, and we'll use it as our move vector. That's our vector right there. So now you see it starts where we want to start, and we need to refine it just a little bit, and then we'll have that in the right place. So we're going from here, and this is moving from our current bottom point to our new bottom point. So these 2 points are the ones that are going to be what we're working with. I'm going to hide that for a second. I think we might need to just reverse that. Turn on the solver. Yeah. And so you see it worked right where we want it to be. And we're going to do the same thing for our second point, and we're going to do the same subtraction, and as opposed to this location, we're going to be moving our secondary location. And so we're going to go ahead and connect this point to here, and we're going to be just duplicating that move command with a different vector. Okay, now that we have this, we can hide our process geometry, and now we have two wonderful lines that will replace our previous lines. And so before we get loft and offset from here, we're going to do it now from these 2 points, and we're going to clean up this code as we get to organize later. Well, this was a necessary way to get more accurate information from our model that could be built. And I'll go ahead and label this just scale factor, so you know what this is. This is where before I needed to do that. And just a little bit of cleaning up. And we're gonna replace where the previous slats were lofted, our solver is off, and we're really just gonna move all this code down over here, and we have our lines from both sides, and we're plugging it in here and here, and we turn our solver on, and now you see a proper straight line that's offset. And remember, as we said, we were using the center point to be consistent. So I'm going to go ahead and copy this to the other side so you see how now we have actually something that looks believable and it's buildable. I'm going to hide some of the previous construction geometry. Don't have too many lines in the model. And we're going to just hunt down a couple of the other ones. Yeah, these are very useful for us, but obviously we don't need to see them. And right before we click into finish this out, we definitely want to make sure that we're where we want to be with our rail, and that code is going to be down here, so we're not needing to really work on that immediately. We're going to disable the solver as we replace this part of the script. Pretty much everything between here, as we see from above, we'll go ahead and click that to make it neater. Everything between here and here has changed a little bit, and we're going to use our distance function later. As I had said, that is very valuable. So if that's the only thing that's changed, we're just going to go ahead and look into here how we derived everything. And again, we have our constant dimensions. We're going to actually put that at the top for our width and our depth, so we don't ever lose them. Those are going to be things that we want to keep throughout. Also, if we need to change them, we can change them. Yeah, so we'll be copying this part, and I'll just go ahead and group it. So we already know that's together. I'll take this out from here, and just remembering those connections. And we're gonna paste that. And as from before, make sure to, as before, gonna make sure to copy that same structure, making the lines. And if we need to change some of these, we're going to do that. Obviously, as I said before, if there are some geometries that we don't use, we're going to take those out as they are no longer necessary. So you get to clean up everything. Alright, so our first line is from going to be that inner, and then the second line is going to be the outer. And then that that third line is obviously going to be a line just connecting the bottom to the bottom. And we just connect these two to make that one. And obviously we're trying to avoid connecting to the front of the model. As the inner and outer, they might not be exactly the same distance, and so I'm putting that into the code already. And so we're going to put that in here. Everything that went to there is going to now go to here. And that's our distance. And finally making sure that we're getting our proper subtraction from our points. And at the end of the day, we want to definitely make sure that everything is plugging in appropriately. I think we're going to actually change this one. Okay, that should be fine. Yeah, and that's supposed to be the proper one. Just go ahead and enable our solver. So we see that we have that same basic center point, and from the top to the bottom, it's actually a buildable piece that's consistent. And if you had built it, you know that it would be even because all the bottoms are the same. Okay. And another thing, so now what we're going to do is also go back, and for the original Serpentine wall, there's actually two slats or two rails in between. I'll show you how to make one, and also show you how I can make others, and it's pretty simple. This is the area of our code right now where we're making our rails, as you can see here. And it's pretty simple actually. To get a center, we're going to use the tween curve, and that's a great one. As we go in here and get basically our offsets that led us to here, and those offsets, of course, is top to top, and that offset 2 on each side. Yeah, so see, one of them was from the top to the top, the next one is from the bottom to the bottom. And to make it easy, we're actually going to put our tween up here as we construct that. And tween takes 2 curves, and it gets the center of them. And this is only for the rail. This is not for a new set of walls or slats. Probably looking a little odd now. This doesn't actually require disabling the solver. And just to obviously make it accurate, it's really going to be the top to the bottom here. And this is going to be bottom to bottom. Yeah, so now you see those are in between. And so our tween curve is pretty much going to do the same thing as here, where we use our merge function to merge the geometry, graph and simplify it so that it takes the pre-existing relationships of that array and makes it into something that can go into our loft function. And we'll pull that back over here, and we'll test it, of course. Make sure that it's 2 arc-like curves. And so now we have a structural slat. And this, of course, can be done derivatively. And you just make new tween curves here between the new curves. It would do pretty much the same thing. And I'll show an example. We get that tween curve. And pretty much we always make a pair. And we take that top curve. We're going to put, just like we did in this tween, these are both from the that first of the inner part of the wall. This from the outer part of the wall. And now we're going to make it from, one's going to be from this, which is our top part of the wall. One's going to be from the bottom part of the wall. Now looking at our tween, we get to do the same thing. tween to top tween and the bottom to bottom. And now you see that we're going to fix that. Make sure that we're getting our proper tweens in here. It gets a little bit tricky because right now it's going from the middle to the top. And all we need is the same as done for here. And this one took the bottom on that side. And what we're going to do to make this one work is we're actually going to go from using our top here and that top point. And just one more change as we make sure we're definitely using the right curves origins. Okay, awesome. Okay, so now we've connected a new structural of the slat. And this is going to be one of the easiest ways, just right off the bat, to get our rails. And we're going to extrude it. Just copy the merge and change to a new set of tweens. Stop the solver, we turn it back on. And so you could do this. And a way to obviously simplify some of this, I'll show you right now, is just take these geometries, and though we've offset it here, create a separate name for each one of them. And we'll say top inner, and we'll say bottom inner offset. And then it won't be that odd going between the different lines. And so we do this here for these guys. And we're going to obviously label the top and bottom for the outer offset. And as we get down to our, I'll just pretty much redo all these just to save a little bit of the visual space. I'll go ahead and make these faint wire displays. And so we obviously knew that we've been connecting top to top and bottom to bottom for our first two merges. We're going to disable the solver so we don't have any conflict. We did top outer and top inner. And then we did, and we'll just leave that together. We did bottom inner and bottom outer. And then when we were doing our tweens, we of course went inner to inner, top inner, and our bottom inner. And then we did our top outer and bottom outer. And then as we wanted to do like a subtween, we actually can go ahead and create a new curve. So we do the same process. And pretty much one of the tweens is inner and one of the tween is outer. And we call it T1. And we just copy one for both sides. So we have our, looking at this being our inner, we'll pop that as our T1 inner offset. And in such fashion, we'll go ahead and plug in. We're going to do something on the inner or something on the outer. We organize them here. And it's obviously inner. We're going from our inner that it's going to be inner to top or inner to bottom. And we obviously have to have a mix to make our rails. So if this is going to be the inner, we wanted to do it to the bottom. So inner to the tween and inner to the bottom. we'll do that one. And this outer to the tween, our first tween. And then we'll have that obviously outer to the bottom as well. And that's going to go from up top. Just make sure we're right. Yeah. Obviously, as we did this is our second tween. I'll go ahead and show you we'll disable the solver if we want to make 5. And there's another method where you want to divide it in parts, but I felt this was much quicker, as you pretty much say, I want to have this many divisions and divisions of divisions. So this last one will be it also from the middle tween. In fact, we're going to copy both of these to make our next set of tweens. We are going to be connecting from the tween as opposed to from the bottom. We're going to connect it from the top. And we're almost there. And our top right here. And that should be fine. Okay, see? So obviously, depending on how many slats we want. And the other method would have been to divide the curve, but I think this is the best way of doing it. But we can show that later in refining it. But so far, now we have all of our slats looking proper and geometric. As we start to offset our rail, we'll definitely need to be looking at the refining. Obviously, you can see that if it goes straight up and roll off that bottom one, you're going to see what one of the issues that we're facing. And I'll just go ahead and just offset surface so you can see, and we'll set a number for the offset. Right now, our rail height is going to be set to 3 inches. So this was for the Serpentine wall, it was a little bit larger, so because we think about the metal, but 4x3, or you can change that for which one possibly your engineer will tell you should use. And so now we have our offset. Now we want to go in the opposite direction. Our top rail can be in that offset, but our bottom one should definitely be a negative, and we're going to use the same rail height for both. This is our bottom. We're going to go ahead and do a negative of that offset. You see it's intersecting here. We're going to show that in refining it. Okay, so in refining it, we'll look into how can we make it so that when we offset our metal piece, and this will also change on the inside. It'll help us out, so we can make our geometry consistent, and we'll be able to plan exactly how long we need our pieces to be. And then we'll also look at some irregular ways of structuring our wall so we can have some generative opportunities.